Hi everyone, thanks so much for tuning in. I'm glad you decided to take our course today. Today we're obviously going to be going over the coding and more practical aspect of the observer pattern, specifically the observer pattern for games design. We're going to be doing this in JavaScript. JavaScript is quite quickly becoming the lingua franca of the internet, and it's so easy to write games for it now in the web. We won't be implementing a game today. We'll just be implementing the very basic structure of the observer pattern. Now, for a bit of setup, I presume you've all done this before, but for a bit of setup, I just have here in my text editor a skeleton of a HTML document with a JavaScript file attached, a blank JavaScript file that is in the same directory as my observer.html, which is being pointed at by our script tag here, and I also have that file open in Firefox Developer Edition. Use whichever browser you want, but I'm not certain of how the developer tools for that work. And I have the developer console open here, which can be accessed here, tools, web developer. I clicked on web console, but toggle tools, what about doing? Just click on console in the bar here. So, to cut to the chase, just ignore this, to be honest, you'll be fine. We're going to quickly discuss the alternative to using it, the observer pattern. And then we're going to get back to the observer pattern and you're going to code along with me. At the end there will be a wee quiz. It's just discussing what we've gone over here, and it should be absolutely ideal. So, typically in a game we'd have a big loop, and in that loop you'll have everything you want to do. You'll say draw list of objects. You'd have your events block. So for I in events, say this is just basically pseudocode. Don't quote me on this. And then you'd have you'd wait for an event, e dot mouse input or something, or I dot mouse input, and you'd have lots of handlers for that. So if mouse input, then you want to handle your mouse input. Maybe just ignore that line, don't worry about that. Anyway, you'd want to manage mouse input this way, so you'll have a lot of handler code in here. Now you can notice already this is quite messy. I mean, this is quite tightly coupled in that lots of objects are all being drawn in the one big block. All of the events are also happening in the same block here. And then further down we've probably got lots of other critical handling things, such as redrawing the screen, clearing the screen, checking for collision, all of that sort of thing. This is messy, and it's very tightly coupled. If one part in this loop goes wrong, the whole loop is broken. It makes debugging a nightmare, and it makes organising your code such that more than one person can work on it an issue. It's not what we want to be working with in the 21st century, especially not when games are becoming larger and more people are being asked to work on them. So, for this reason, we're going to create an example of how the observer pattern would help with this somewhat. We're not going to go too in depth, don't worry, this is just going to be structural. It's just going to show you how it will basically work in structure. So, to get started with, we're going to create an example game, like a fake game. Remember back to your object-oriented tutorial days when you had dog and dog barks, and you'd maybe have like a cat which inherits from animal, as does dog, but instead of bark you'd overwrite bark, or maybe sound noise to say meow. Probably even simpler than that, to be honest. So if you could manage that tutorial, you'll manage this no bother. So without further ado, we're going to set up an example. I'll say we'll have an AI. Say this is like a shoot 'em up game, like Missile Command. We're going to have an AI class, right? We want to have an AI class. We're going to have a player button, or rather a UI button, we'll say, for pressing. And we're going to have, obviously, this is the key part, an observer. Now, as we went over before, the observer's job is just that. It's to observe what's going on its object. In this case, the object is going to be, or rather subject. The subject is going to be the UI button. So we're going to create an observer. So we'll start off with the AI. The AI is just going to be, it's going to have a name, In fact, no, it'll just have a type. Our observer will, no, our AI will just have a type. This dot type equals type. This dot, and it will have a notify function, and I'll discuss that once I've typed it out. Sorry. This dot notify equals function. Okay, and what's going to happen is if this dot type is equal to goody, then you want the goody AI to come help you. So it'll tell you it's going to help you out as best it can. I'm coming to help. And if it isn't a goodie, then obviously I'm a bit black and white in my game world, so I'm going to say that, no, not page transition, thank you very much. If it's not a goodie, then it's got to be a baddie, so it's going to say, I'm going to steer away from your missiles. Yeah, so that's quite straightforward. This is a very, very basic example, like I say, so we'll be absolutely fine. Yeah, our next thing to go over will be our UI button. So it'll be quite straightforward as well. We'll have and it will take an observer as a parameter. And you'll see why in a second. I'll discuss why, but we'll just get the basic code out of the way just now. And its job will say, so what it'll do is it'll also will create a spoof function called press, and what happens there is it mimics what would happen if you had a button in the game and it was reacting to an event whereby it was pressed. This is quite trivial in JavaScript. In vanilla JavaScript, it would look sort of like so btn dot, or in this case UI btn dot on press inside a game loop. So it would be quite straightforward, and you just call this method. So this is a callback essentially. I'm sure you're familiar with callbacks if you want to learn about complex design patterns like these, or rather not complex but less trivial design patterns. So what will happen when it's pressed is we want it to output to the console missile firing, so that we know that we've actually done something. And in the process of this, in fact we'll come back to this in a sec, give that a quick save. The AI here takes a type so that we know whether it's a goodie or a baddie, and it just outputs to the console what happens. The reason we're calling this function notify will become clear now that we're going to implement the observer. The observer is really the glue that's going to hold this all together, and you'll see why in a sec when we make it. It'll be the most difficult one too. There are some parameters that an observer class must have in order to function, or must essentially an interface that it must abide by. So in this case, it needs to have a subscription method. So this dot it needs to have a way to unsubscribe, and it also needs to have a way of telling the people subscribed to it, or the object subscribed to it, what's happened, or that an update has taken place. In this case we're going to do this quite manually, to be honest. So yeah, by just calling the broadcast method, and you'll see how this works in a second. So we'll want to have a list of subscribers too. So when someone subscribes, what we want to do is say this dot subscribers dot push, and we want an object there. I've forgotten how to type. This is what assignments do to you. when someone unsubscribes, we want to find that object that is in there and remove it. So we'll say this dot subscribers. So what we'll do is filter out the we will filter out from the list the chosen object, which is a parameter, and when that happens, we'll just set it to be subscriber. So the subscriber list will say for every for every element in the list subscribers here that is not the object we've passed in, keep it there, filter out the one that is the object being looked for, and then set that list, which does not include object here, to be the new list of subscribers. So it's quite straightforward. It's not equal there we go. So that should work fine. And this is as complex as it gets. So literally all we're doing here is filtering out the object that we don't want to be in that list anymore, and then that new list is being assigned back to subscribers. And when we broadcast, we need to say we're going to go through each subscriber, kind of like a new service again, like in the intro video. For each subscriber, we're going to oh no, that's not what I wanted to have happen. For each, we're gonna say I.notify. So what's going to happen here, this is the crux of it, is for each person subscribed to our observer, we're going to go through the list of everyone in that list, and if they have a notify function, which they'll have to do if they want to be an if they want to have access to an observer. This is the interface here, right? This is where it all comes down to it. For everyone who is a subscriber, you're going to go through it and you're going to trigger their notify function. This way they now know that the action that they are looking out for, in this case a UI button click or press in our example, has happened. That's all this is. You subscribe to an observer, the observer tells you when it happens, you can then react to it in a notify function. That means that all of the action code for one event happens in one place inside the class of the actor which wants to act upon an event that's happened. The observer just looks for this event to have happened, and then when it has, it broadcasts, or you tell it to broadcast to all of the people subscribed to this observer. In this case, what's going to happen is we're going to say if it's possible to set a UI button with a null observer, just in case you're a mad person. So we're going to check for that just in case, just for funsies. If observer does not equal null, we're going to say observer.broadcast, because we want the observer that we've tied into our UI button to tell everyone that the event that is being observed upon has happened. So we'll set up a quick example using these prototypes. It won't be much longer now, I promise. We're almost done. We'll create a new UI button. Well, first off, we'll create two new AI. We'll have body equals new AI body. We'll call this body Steve, actually. Steve. Var Johnny equals new AI Goody. I'm a good guy sometimes, depending. Anyway, we'll also create a new observer. We'll call it button watch. Say, equals new observer, and it is just going to be on its own. And we're going to create a new button. Var new missile button. Yeah. and the observer watching it is obviously button watch. So that's that. So what happens now is if we launch a missile from our missile button, what should happen when we run this code, if I haven't made a mistake, and if I have, please bear with me because it won't take long to fix, because again this is quite nice code if I do say so myself. What's going to happen is each person is going to be notified, each observer or each subscriber to the observer button watch, which is watching our button, is going to be notified of the button pressed and is going to react accordingly, which is very nice. So fingers crossed that this will actually work, but you can see how simple the example is here. So in our console we should see, oh, the stop broadcast is not a function. I might have forgotten to implement that so far. Did I spell broadcast wrong? Oh, I see. Okay, I've gone and done a stupid. There we go. See if this works. Fingers crossed again. Missile firing. Oh, this subscribers.for each is not. Okay, I think I've spelled for each wrong as well. Here we go. Don't make the mistakes I did. This is another lesson, kids. Right. Okay, so what I've done there, for those of you who weren't paying attention, is I didn't set up a subscriber, so no one was actually subscribed to Button Watch. So we'll subscribe Steve to Button Watch first, and we'll also subscribe Johnny. There we go. And now when we run this, you can see the baddie, Steve, steer clears the missile, and Johnny, the goodie, comes to help, which is good, which means now if we also thereafter unsubscribe and then press the button again, unsubscribe Johnny, what happens is if we press the button again, what should happen is we should see the missile firing again, but only the body should be there. Ah, okay. Coding error, just a sec. I've defined this here. Okay. I have had very little sleep, you'll have to bear with me. Grand. So what's happened the first two times is a missile's fired and both have reacted. Second time, only the baddie has reacted because we've unsubscribed Johnny the goodie from the observer. So the good thing about this pattern, to quickly summarise, is that it means that your code is quite loosely coupled. So if you want to add a new class to observe something, all you have to do is give it a notify method as part of as its interface to the observer. So we could create another class, an example. So I don't know, maybe pet. I don't know what the scope of this game is, but you could add a pet, you could add a planet or something. It's provided it has the notify interface, then it can also observe any button in the game. Whereas before we'd have to create another complex loop in order to account for that. So this makes the whole process much easier. It's also really good because we can break things down into separate units or classes which people can work on separately under source control, which makes your life much easier. So yeah, we've gone from a massive messy loop into this in a short space of time, which is quite nice. I would have tried to keep this more brief, but hopefully you've been able to follow along at home, no bother. If you have any questions, our contact details are on the Udemy course, details on the side. And from me, thanks for watching. I hope you found this useful. And stay tuned for more from our course in the future. Thanks.